evening, participants, and welcome to this evening's webinar, STEM with TI-Inspire. My name is Brian Lannon. I'm your host for this evening's webinar. Tim and Peter are your presenters. That's Tim Grabovszky and Peter Fox. And Tim and Peter, are you there?
Yes, I'm here. Good evening.
Hello. Good evening to you both. Both very experienced presenters, and I have attended sessions from both these gentlemen working with the latest addition to TI-Nspire technology, which is the TI-Nspire Innovator Hub, a wonderful piece of kit. But in order to get the data, the data into and out of the hub, and to have the hub doing something with its both its sensors and its actuators, it does require a bit of coding. So we're going to talk to Tim first, who will tell us a little bit about how we can code on the TI-Nspire. Following that, we'll then switch to Peter, who will tell us how to use that coding to do some clever things with the Innovator Hub. Enjoy. All the best, Tim. Bouncing ball is with you.
Thanks very much,
and we
Brian.
see your screen. Cheers, Tim.
Anyway, good evening, everyone. Yes, I'm a teacher at the Hutchins School in Hobart, and I'm hoping to take you through some fairly simple coding this evening. My aim is to get through 3 programs to just give you a bit of a heads up on what you can do on the TI-Nspire. The first program that we're hoping to get through is this one here called Heads and Tails. And if I quickly run the program to give you an overview, to run the program I just hit the variable key and it brings up the program that's currently stored in there. To run that program I'm just going to hit the enter key, and what we're doing here is we're tossing a coin a number of times. So I'm going to toss a coin, say 1,000 times. And what it's done behind the scenes is it's randomly counted how many heads, how many tails, and then spat out for me the experimental probability for the number of heads based on that data, and then just compared that to the theoretical probability. So we'll have a look at the programming behind that one. From that one we will move on to this next one, which is called a list of perfect squares. And I'm actually on an interactive notes page here, and what we're hoping to do is create this slider whereby as we move it, it will generate a list of perfect squares between 1 and wherever I happen to stop that slider. So that's the next program we're hoping to look at. And time permitting, we'll get into this little program here called Simulate Pi. And what this one will do is when I run it, I'll just hit my variables again. I've got this program Simulate Pi. I'm going to run that program. What I'm doing is going to say I'm going to run 1,000 trials for this program. And it's told me that based on this trial, it's giving an approximation to pi of 3.12, and we'll see what that's all about as well too. So that's our aim, is to get through those 3 programs. So the first one that I'd like to look at is this one here, Heads and Tails, and have a look at what's behind the numbers coming out of this program. So what we'll do is I've just got a fresh blank calculator page here, and I want to get into the programming side of things, and there's a number of ways you can do this. I'm going to go Control Add Page, and from here you can see your submenus. I want to go into the program editor and create a new program. This is where we give the program the name, and I'm going to call it Heads and Tails. Don't worry too much about the other things here at this stage. We're going to go into OK. And what it does is it gives you a template to fill in. And this is all written in TI Basic. This is the name of the program. And down here is where we're going to start putting in our code. Now, the first thing I want to do is enter a command called local. So to enter all of the programming commands, I'm going to hit the menu key, and under define variables, you'll see this thing called local. Now, you could have just chosen to type that in if you know what you're doing, but we can access everything through the menu command as well. Now, what local does is it tells the program to only use the variables while this program is running. Because if you're outside this program, you don't want these other variables available sometimes. So I know that I'm going to have a variable called toss, separated by another variable called heads, another variable called choose, and another one called j. They're my variables that I only want to be local to this program. Another good idea is to maybe actually write your program and then go back to the beginning and put in your local variables then once you know what they're going to be called. I'm going to enter a request command. So I'm going to go to menu, and I'm going to go to input output. IO stands for input output. And I'm going to choose this thing here called a request. Now what this is going to do is it's going to prompt the user to enter the number of trials that we're going to run in this experiment. So I need to now follow this with some quotation marks. On the handheld, if I go control multiplied by, I get my quotation marks. Anything inside there is treated as text. And I'm going to type in enter the number of coin tosses. And outside that, I'm going to put comma toss, because whatever number I choose, that's going to be stored as this variable toss. So if I want to run this experiment 50 times, it's going to be stored as toss. Okay, I've just hit enter again and I get a new blank box appearing. And what I'm going to do now is set a counter. And I'm going to call my counter heads. I've just typed in the words heads. And I'm going to define that counter to be 0. Now, if you hit the control defined key, you could alternatively use the keyboard if you're running the software. I'm going to set my counter as 0 because currently I don't have any heads. Enter. I'm now going to get into a for statement, and this is basically the crux of the program here. So again, everything's under the menu commands, and I'm going to go to control this time. And you can see quite a few little sub-menus here. I'm going to choose number 5, which is the for command. And again, it gives me a bit of a pro forma or a template of what to put in here. And when I was learning a bit about programming, I was alluded to the fact that you think of this a little bit like a sigma notation in mathematics. So what I'm going to do is I'm going to go from J, starting at 1 and finishing at toss. And it's a bit like sigma notation. That's my variable J. I'm starting with 1 toss and I'm going to finish at whatever my number of tosses were. I'm then going to jump down into that next line, and I'm now going to set another variable called choose, and you can see that again in my local command up here. And again, I'm going to define that to be, so control define to be, it's going to be a random integer. Now, if you're not sure of the commands, we can actually access built-in commands from the book key here. So if I hit the book key, and if I type in R, it will take me to all of the commands here. And there's one there called random integer. If I choose that, I'll just hit my enter key, and it pastes that in. Now, if you know what you're doing, again, you can just type that in. And I want to choose a random integer between 0 and 1. So So it's either going to choose 0 or it's going to choose 1. I'm then going to go to a new line again, and then I'm going to put in an if command now. So under the menu, I'm going to go to my control, then I'm going to go to my if, then, and if, and choose that one. Because what's going to happen there is if my choose happens to be 0, then I'm going to go down here, then my counter, which is heads, my heads counter up here, is going to increment by 1. And so now I'm going to define that to be my previous heads value plus 1. And that's pretty much the crux of the program here. So what's happening is we're choosing a random integer, either 0 or 1. If it's 0, we're calling it a head, and then my head counter increments by 1. Then I've ended my if statement and I've ended my for statement. And that's basically the program, but now we want to display some output. So I'm going to hit enter again to get a blank box. And to display some output, I'm going to go to my menu commands. It's under input output because we're displaying some output. And you can see this first one here, disp. That's going to display some output. I need to follow that with some text. And what I'm going to do is display the number of heads. My heads were equal to, and just leave a bit of a space there, and what I'm doing is inserting my variable. So this is going to display the number of heads based on this counter, and you'll see it on the screen. I'm going to hit enter, and I'm now going to display, so I can just type it in because I know what I'm doing, so I can just type it in, and I'm then going to choose my quotation marks again, and this time I'm going to display my tails. Now, if I know my number of heads, my number of tails must be my total minus my number of heads. And that's going to generate the number of tails for me. I'm going to hit enter. And there's a little command here that's going to just set everything to approximation. So if I go menu, my mode, I'm in a mode here. And what I can do is go into approximation mode. So if I go to number 5, and I want to go into approximation, and the reason that I want to do that is because I want to get a decimal. I don't want to get an exact fraction. It's easier to visualize, I think, if you have a decimal. And all that command does there is set the computer to approximation mode. And the next thing I'm going to do is another display command, so DISP again. Some quotation marks, and here is where I can now calculate my experimental probability. So the experimental probability of a head is, and I now want it to display, so I've got to put in my comma, I now want it to display the number of heads divided by my number of tosses. So that's just a fraction that's going to appear, or we're going to convert it to a decimal in this stage. And the final thing I want to do now is display again the theoretical probability is, and we know that that is a half. So I'm just typing in 0.5. And that's basically my program. So I've got my program running. I'm going to display my things. And now to finally save my program, I need to check the syntax and make sure everything's okay and store it. And to do that, I'm going to hit menu. And up here, number 2 is check syntax and store. And I'm going to choose number 1. And you can notice in brackets it says Control B. So if you're on a keyboard, it's very quick and easy to just go Control B and it will do that automatically. Assuming I have made no errors, I will get a stored successfully command at the top. If you have made a little error somewhere with your syntax, you'll get an error message, and you then need to troubleshoot and find where that error may be in your program somewhere. So we're now going to see if this program works. So I'm just going to go back to my calculator page here, and I'm now going to run that.
Just while you're doing that, Tim, I've just sent out a live poll just asking people about their programming experience, which might help direct us there. Yep. But,
all right.
Yep, I reckon it's great the way you're showing us this.
Okay. I'll just wait for a few of those polls to come in then, will I?
Oh, you keep doing your thing. I'm finding we've got it's very spread out. So I asked programming experience, and we've got some that have never done it before. Some have done a bit. Some have done a fewer amount have done a reasonable amount of programming. And there's a few who have done it with the Innovator Hub as well.
Right.
So thank you, participants. That helps. Yeah.
Now that I've saved my program, I'm back in the calculator page here. And if you noticed earlier on, I said to access your programs, you just hit your variable key. So I'm just going to hit the variable key on the keyboard there. And it should have my program listed there. And I can just choose that program. It gets pasted in. Alternatively, if you remembered the name of your program, you could have just typed it in. I'm just going to hit enter, and we should see that program starting to run. So how many coin tosses do I want to do? I'm just going to go for, say, 500, and hit enter. Based on this experiment, I ended up with a random number of 240 heads and 260 tails. It's then divided my heads by my number of tosses to give me my experimental probability, and it's then just comparing that to the theoretical probability. And so that's just an introduction to, a very simple thing that you can do there to simulate the number of coin tosses. It makes it a little bit more exciting than actually doing this in class, 50 times and tallying it up on the whiteboard. It gives them some coding experience as well too. So that's that first program there. So Peter or Brian, did you want to add anything before I jump into the next one?
Well, I was going to say, Tim, I really like, we've had various ways of simulating this before, of course, using the Inspire and the random number generators that are in there. What you've added in is a much higher level by putting in the coding, because as you said, it gives students that coding experience, and it shows them a bit more about what's inside that black box. How are these things done?
Exactly.
So I think that's really quite powerful, and using a situation that they're already all very familiar with.
Okay. All right, I'll jump on to the next one. I'm conscious of the time. I don't want to take too much time away from Peter, who's got a little bit to give. So I'll try and get into the list of perfect squares here and get into how this program here is running. Okay, so again, to do that, I'm going to open up a new document. So on the computer, I'm just opening up document number 6, and I'm going to go into my program editor again and open up.
Can I just point out there, what you're doing there, it requires the latest operating system 4.4 to be able to open that up as a new page, as a page type. That's only just been added in OS 4.4. We might have some people watching thinking, wow, where did that page come from? I don't have operating system 4.4, so how can I do that? Well, there are ways to still open up a programming page just from a normal calculator page, and we may be able to show you that. But I've just opened a poll asking people if they are up to operating system 4.4 yet or not. But this can work. This will still work with the older operating systems. You just don't get that instant page.
That's a good point, Brian. Thanks for that. Now I'm going to call this program square numbers in a list, because I'm going to have a list of square numbers. Now, if you haven't done much programming here, it's important to know that we can't have any spaces, and we can't start with a numeric digit. It's got to be letters. You could put in an underscore if you wanted to simulate a space, but just be aware of some of the syntax there. I'm going to go OK, and again I get that little template to help me build this program. Now, for the sake of speeding things up, I'm not going to put in any local commands here. I'm just going to jump straight into the program. What I need to do is set an empty list, and I'm going to call this square in a list. So my program is called square numbers lists, and I've got another set, and I'm going to define this set to be an empty set. And to bring up your set notation is actually under, or you hit your control and then it's your right brackets. That is my set command. So I've got an empty set being defined to be the square in a list. Okay, then what I'm going to do now is enter the element number of that list. So I've got this thing here called T, and I'm going to define T to be the first element in that list. As the program unfolds, you'll see what this T represents. But basically that 1 is going to represent the first element of this list that will get created. I'm now going to jump into the main part of the program, which is the for statement again. So I'm going to go Menu, Control, and I'm going to go number 5 again, which is my for end for. And again, it gives me that little pro forma to fill in. I'm going to start with something called J. And again, with Sigma notation, it's just like starting with J or N in your Sigma notation. And I'm going to start at 1 and finish at N. And N is going to be my slider that I move that controls where my limiting list of square numbers is going to be. I'm then going to go into an if statement. So to access my if statement, it was under control again, and number 2 is the basic one to go for. And I get my if statement up here. And there's some nifty little features in the calculator itself. And now to get my perfect squares, what I want is if the square root of J, because J is the number that I'm starting with, if the square root of J happens to be an integer of the square root of J, and I've just got to put my brackets around that. So what that is saying there is that I'm going to take the square root of my number. If it happens to be an integer, then I'm going to add it to this list. And that's what I'm going to put down here. So what's going to happen is that list there, so square in a list, that is going to advance by 1. So I'm going to change that to T plus 1. So the first element in my list is going to be whatever the first perfect square is. As soon as I get another perfect square, it's going to add that as the second element in the list, and that process is going to keep getting repeated. Actually I've made a little bit of an error there, I think. So what I've got to do there is, yes, I'm just going to backspace there. They're going to let me backspace. What have I done there? So I'm just going to come up there and backspace that. Because what I've actually... Sorry, Brian, did you want to cut in?
I was just going to say, yep, you're onto it there, that's good.
Okay, so what I actually need to do here is put in these square brackets, because that is going to be the element of my list, and that is going to be defined to be my J. Okay, then on my next line of working, that's where I need to increment my list number. So what's happening here then is that, just recapping this, I've got my sigma notation here if you like. If the square root happens to be an integer, then the first element of my list is going to be that J number. And then I'm going to increment my T by 1 and start that process again. So that is the crux of the program there. I can then save it. So to do that, I can go Menu, check Syntax and Store, save it. Says I've done all the right things. What I now need to do is go to my interactive notes page. So I'll go Control, Add a Page, and I'll actually want a notes page now. And if you haven't played around with interactive notes before, it's very, very useful. I want to introduce a slider. So I'm going to go to Menu, and I'm going to insert a slider. And it has to be called N, because that's what I called it in my program. I can't use any other variable there. Its current value is 1, and I want it to start at 1, and for the sake of this, I'm just going to end it at 100. And my step size here, we can leave it at automatic, but I always like to enter a value. And I'm going to enter a value as 1. So it's going to increment and count up by 1. I'm going to leave everything else as default and go OK. And I get a nice little slider there. I just want to make it a little bit bigger. So on the computer I can just right mouse click and choose Move and make that slider a little bit bigger. Okay. Now I've got my slider going there, but I actually need to run my program. So I have to get into the math box. So what I did there was, I'll just jump back a bit. I'm on a notes page, I'm going to go Menu, and I have to insert a math box, because on a notes page, if I didn't put a math box in, it's just going to be text. I have to actually have some mathematics going. And so now, if I hit my variable key, I should see my program there. I'm going to choose my program, and I'm going to get Enter, and it says Done. But I can't see anything. And that's because in the program, I need to now look at my list. So I'll just hit Escape. So I've run the program, but nothing's happening because I can't see the list being generated. So I'm going to hit my variable, and you can see this list thing here with the brackets. I'm going to choose that, and then hit Enter, and it should now start to generate a list for me. So as I come up here and grab my slider and move it, as I move it along, I should see my perfect squares start to generate. And I think that's really nice because it's interactive and you can see it unfolding as you move that slider along. And before I end that and hand over, I just want to show you one very quick change to, say, generate the list of prime numbers instead. I've currently got my perfect squares. If I jump back into my program, I'm just going to jump back, I've just changed tabs there, jumps back into my program. The only thing that I need to change is this command here. Okay, so all I need to do there is now put in this thing called isPrime. So if I go to my book menu, if I go to I and scroll down a little bit, there's a thing called isPrime. So it's a fair way down, and there it is there. So if I choose that, it pastes it in for me, and what I need to do is I need to check J. So this is saying, is J going to be a prime number? And if that is true, then it's going to stick that in the list. Now if I resave this, so I'm going to go Menu, check Syntax and Store, and save it. It says it's successful. If I now go back and run this program, my list is now generating prime numbers instead of perfect squares. And it's a very quick change in the program to do that. So once you've got these templates there, you can easily change things to generate whatever list you like. Now, I've probably gone a little bit over time, so I apologise, Peter. I'm going to hand back to Brian, who will introduce Peter.
Yeah, well, going over time there was fine, Tim, because I think it's actually really clever what you've shown us. Participants realise what you're looking at there. We just saw a notes page containing a slider and a program built into it, and you saw the coding of the program and how that coding could be modified. Tim, I reckon the activities you selected for us are very well considered and put together.
Thanks.
Yeah, well done. And I think it just gets even better, participants, just when you think everything's wonderful, it gets even better because as part of the webinar, you will get a copy of those files along with your participation certificate following on from this evening's webinar.
And Brian, I just want... Sorry, Brian. I just wanted to add in there. I was planning on to get onto the Simulate Pi, but obviously, you plan too much for these sessions. But those notes will be available on the links to the webinar later on, as Brian suggested.
Thanks, Tim. Can I encourage people to really look at that Simulate Pi one as well? Tim sent me these files earlier on, so I've already had the opportunity to have a look at them. I really like the Simulate Pi one. Look at that word simulate. It actually uses a Monte Carlo process to come up, which some of you may have seen before in various ways of developing that. But to put it within a program, I thought was very clever. So there's more good things coming your way. Okay, thank you for your participation in the polling, as I've been doing along the way. And also, it seems that just about everyone's on operating system 4.4, which is great. If I get the opportunity at the end, I'll show you how to upgrade to that if you haven't already. And yes, can I just reinforce, if you do wish to ask questions, maybe questions of Tim now, while Peter is presenting, type them into the chat panels or into the Q&A panel directing to all panellists. That way Tim and I will be able to read that. But meanwhile, Peter is all set, ready to go, and it's an interesting picture on screen there, Peter. What's going on?
It is. You'd probably be familiar with this, Brian. We were over in Chicago earlier on this month, and a good friend of ours from Queensland, Mr. Rodney Anderson, was presenting a lovely session. And one of the components to the session, because we're in the US, we wanted to know how many helium balloons it would take to elevate or float a koala. Well, of course, we weren't going to try and import a real one, so Rodney took over I'm going to say a stuffed koala, and the participants...
Is it dependent upon how much eucalyptus they've been chewing?
Well, yes, that's very true, yes. So the experimental setup, you can sort of see. I was going to try and show it on the camera in here because I'm going to try and emulate what we've got there, but the camera's not working too well, so what I will be able to do, however, is still show the data as it comes in live. So the idea is that we want to just continually attach hot air balloons or helium balloons to a force probe, and we want to see what the result is. So I'll go through the setup of it, and I will also collect some data, and we can have people take a guess. And let's say rather than be cruel and float a koala, let's imagine you're going to float your calculator. Now, I'm only saying that not because I want people to try and send their calculator up into the air with helium balloons attached. It's because if you've got one sitting on your desk, you could take an approximate measurement with your hand, and that's what Rodney did in his session there, is he had participants hand around the stuffed koala and try and estimate the mass or weight, depending on which way you want to think of it, because we are measuring force. So therefore, he was looking at people estimating the actual mass of the koala and therefore using the graph that they generated to try and predict it, which I think is a lovely end to a lesson, that students would use the mathematics and have some sort of simple prize. It could be a block of chocolate, but the only problem with the block of chocolate, it actually tells you the mass of the chocolate, so it's kind of cool that it's something that doesn't have the mass written on it. Anyway, enough of that information. So what we've got here is when you first connect the force probe, it may or may not have a reading on it. So what I'm going to do is just hold it vertical, and you'll see that it does change ever so slightly because of the actual weight of the hook that's attached. So the first thing I want to do is set up my probe, and you can see that there's a option to set up sensors, and it's automatically detected that I've plugged in a dual range force probe. Now, if you're wondering how I've connected this to the calculator, there's two options. I'm actually using a lab cradle, which is a device that slides onto the back of the calculator and allows you to connect up to 5 different probes at once. You can also do it using like a GoLink probe, or GoLink connection, which plugs direct into the top of the calculator and go in that way. So I'm using something called a lab cradle, which people can look up afterwards on the net. So first thing I'm going to do is zero it, and you'll see that we get back to something that's pretty close to 0. Now, by default, it thinks I want to measure things over time. I don't. I can click on where it says mode, where my mouse is pointing at the moment. I find when students using the calculator, rather than using the mouse, they tend to use the menu keys. So, same thing though, collection mode, and then we see the options. Alright, so we've got time-based, events with entry, or selected events, so you can wait until it gets to a particular value and then select. I'm going to do events with entry, and I'm not going to give it much information, I'm just going to call it events. And we're ready to go. Now, it's not measuring anything, well, it's not recording anything yet until such time as I press start. And you'll see the little camera appears. At first that may not be obvious. Don't be scared. It's going to take a photograph of me. It's just saying, do you want to keep the current recording? And I'll say yes. And here's where it props up and says, what value do you want to assign this? Well, I've got no helium balloons attached at the moment, so I'll say 0. All right. It's still measuring 0, and it's waiting for my second reading. Now I'm going to put the phone on speaker because I can't handle all of this stuff at once, so we'll see how we go. So we're attaching 1. And just let me know, Brian, if people can't hear.
I can hear okay.
Oh, and I'll click on my little camera tool, and it's kind of good because it says the previous value. I think that's quite handy because with my memory I would probably have forgotten what the last value was, because it may not be something simple like adding balloons to this situation. It might be something else where you need to type in a specific value. I'll click on OK. Not a lot happened so far, but it's added some points to my graph. I'm putting another one on. We can see down the bottom where it says run 1, you may notice that the force on the force probe has now changed. I'll click again, and now I have 2 balloons attached, and we're ready to go for the next one. I've set all these things up before, so we've got little strings on them. The thing I didn't do was get really fussy about the size of the actual balloons. You should try and get them about the same size, but yeah, it's experimental error. Now we have 3 of them attached, and we're ready to go for the next one. See if I can get the next one on. Wait for it to settle a little bit, and we'll start. Now, the reason, of course, while it's jumping around a little bit is because obviously the balloons move about around a little bit. We'll click on 4, and I hadn't seen Rodney do this before. I hadn't done this actual experiment before, but I quite liked it. I was impressed with the result. That's why I'm doing it now, obviously. So let's grab that one. That's 5 of them now attached. See for the next one. Settling down. We'll snap that one right about now, I guess. That's 6 of them attached. And that's probably enough to give us an idea on what's going to happen. I'm just going to hit stop. I've got one more I could have connected, but let's just assume that's enough. Now, I can take it off speaker. There we go. So, whereabouts is that information? Now what I'm going to do is I'll add a calculator page, because I just want to show that these variables have been recorded. So when I hit the variable button, the one that looks like a little list, the two down the bottom, run one force, they're recorded ones. The two above that are numerical values. Now let me demonstrate the difference. So if I choose the force one, it just generates a list of all the values it's recorded. I'm pretty confident it didn't record them with that level of accuracy. However, that's because of the mode that my calculator's set in. But let's have a look at another one. The meter events, if I go down to meter force, now we know force isn't measured in meters, it's referring to it as a physical meter. That was a bad pun from an ex-physics teacher. And it says currently it's measuring negative 0.94. That's because I've moved it around. It's now facing the other way. Here's something that's really cool though before I start graphing it. I'm going to go into a notes page and do like what Tim did before and just drop a maths box in. And let's pop that in there and press enter. And it's actually measuring it live. So if I change the force on it, I think that's pretty cool.
Yeah, that's great.
That's just me being a silly geek. Anyway, let's drop our, we could do it on a data and statistics page, and we can say, let's have a look at the event. Now I could have called that balloons or something. That would have been a more sensible name rather than event. And force, that's actually remarkably linear. I mean, we'd expect it to be roughly linear. I would have thought there'd be a bit of jostling with the balloons as you try and attach them and they move off to the side, but I know Rodney did it with about 10 or so at the conference, and we still weren't seeing much deviation away from that straight line. And we didn't measure the balloons in terms of making sure they're the same size. We still get something that's pretty linear. Now, there's numerous ways that we can then work with that. You can get students to come up with the equation. That's my preference. For the time here, I'm just going to do a simple regression. As I said, if I'm in class, I would much rather the students come up with the equation themselves. Then there's the interpretation of what's going on here. The constant on the end is the fact that we didn't have a perfect zero at the start. And of course the alignment of those points. The one I'm more interested in at this stage is the gradient. So what does that actually mean in terms of my experiment, trying to get an understanding of it. And that's good regardless of whether we're talking about a science subject or a mathematics subject, that the kids are deriving meaning from this graph other than, oh, it's a straight line. The fact that each additional balloon means we have provided an additional upward force of roughly 0.2 newtons. Then, of course, the job for the students is to say, well, I think the calculator weighs, let's say, 100 grams. How many newtons is that? And then work backwards to figure out how many balloons I'd need to attach. And, of course, the best thing is you can always test it. But if it's something as heavy as a calculator, just a word of advice, you're going to need a lot of balloons. It's pretty heavy. So I'd suggest something a little bit lighter than a calculator. But people might try and estimate that. Brian could even do a quick poll while I'm setting up the next one.
Okay, I will do that.
Using Innovator. So how many balloons, we'll leave the equation up there for a second, how many balloons do you think you would need to float a calculator? 0.2 newtons roughly, upward thrust from each balloon. All right, so while Brian's typing up that quick poll with no prior notice, I'm going to hook up something called the TI-Innovator.
And you're saying the calculator 100 gram?
Well, no, I want people to guess. Well, otherwise, everyone's going to get the same answer, Brian.
Okay,
so they can guess
it's not a 100.
How much they think that thing weighs. It's a bit cruel, isn't it?
Okay.
So how much, or how many balloons to float a calculator? And can you leave it open, or are you going to have to put in? Can they just type a number in that poll?
Oh, I think it's just type a number in. I'll just see what happens.
Now, whilst Brian's doing that,
I
don't want that one. I'm going to start a new one. All right, so we'll let people think about that one. And Brian mentioned something before, because as Tim just went straight to Program Editor, if you're using an operating system older than 4.4, then you can just click Add Calculator, and once you did that, you'll see that there's an option for functions and programs in the menu. And then if I include that one and then ask for a new one, we get the same dialog box as we had before. I'm going to call this one Light, which we'll see why in just a moment. Click on OK. And this is the bit that's annoying. Once that screen pops up, you'll see that you've got a vertical split screen. And on a computer, that's fine. On a calculator, when you start typing in a lot of syntax, it scrolls off the edge. Great shortcut for people to know is Control-6. And what that does is split the screen into two. And the program, because it's on the right-hand side, jumps onto the next tab. So, we're going to connect up this little device called an Innovator. And shortly I'll try and bring up a picture of it. You may get a picture of me, so I'm just warning people in advance in case they're scared, seeing my picture up on the screen and my messy study. So how do we work this little Innovator thing? So one of the things that's new in 4.4 is this ability to connect to Hub. And what is a Hub? It's a little electronic box that contains a circuit board called the TI Launchpad, which is generally used by engineers, electrical engineers, to program stuff and make things happen. So you want to create a complete circuit and do some really cool stuff, then they would use that. But that's not particularly accessible for high school students. A small handful of teachers may be able to do it. So what Texas Instruments have done, have put it in a nice little box and made it very easy to code and code it from the computer. So we'll see how quick it is to actually program a microprocessor. And I don't think this is a trivial thing. We are programming a microprocessor chip. So the first thing I've done is I've sent this statement called begin. Now, we're discussing whether or not that needs to continue, and you don't have to worry about all of those little commands, delete variable, IO string, string 0, etc. All it does is wipes out what was in the chip before, because we want to start with a clean slate. Now, as you can guess from the name of the program, we can do something really simple to begin with. All we're going to do is switch a light globe on and off. Now, when I say a light globe, I'm actually talking about a light that is built in to the actual Innovator board itself. All right, so we're talking to the Innovator, so we go into Hub, and we want to set something. We can connect output, because you can connect up complete electronic circuits, motors, diodes, all sorts of sensors. So let me just escape back one. So send set. And I don't think it's rocket science there that we just need to set a light. So I'll set light. Then we need to know what exactly do you want to set the light to do. Well, I want to set it on. So I'll go back menu, Hub, and it's a setting. What settings have we got? On. Now I could leave it at that, set light on, but then it's just going to turn on and do nothing other than leave the light on. And my parents always told me to turn the light off when you're finished, so I shall do that. Now I'm not going to tell it to turn it off. Instead, under here, I can just set it to go on for a certain amount of time. And I'll put in something like 5. And that's it. That's all we need to program a microprocessor chip. I think that's reasonably easy. And the syntax is easy. Set light on for 5 seconds. All right, so as Tim taught us before, Control-B, and it's stored successfully. And then under my variable menu, as Tim showed us before, and people should start to recognize these little symbols up here. The 1.0.1 thing is a program. And I'll press enter. And that's really cool from where I'm sitting, but for everyone else out there watching the webinar, probably wasn't all that exciting because they didn't see much happen. So let me see if I can put a screen on, and I'll try not to scare anyone. Let's see which screen it shows. Oh look, it's gone to the right one. That's a good thing. So there's our little Innovator box. And with a bit of luck, you'll see just in near the plug, a little red light went on. We'll do it again, and you'll see a little red light come on. That's just a little diode, that's it. So not a lot of joy there. I mean, we've got a light to turn on. We could turn it off and on to whatever command rate that we wanted to, but I want to do something with a little bit more oomph in it. So I'm going to leave this on, but what I'm going to do is get rid of this command, and we'll try a different command. We'll go hunting for stuff. Right? So we're just exploring. So menu, hub, send, set, color. Now, I could type in some numbers here, but it's a finale, right? So I'm going to set R, and people can figure out what's going on here. I'm going to set R equal to 0, and then I'm going to start with 4i from 0 to 255. I'm going to go in steps of 5 because I've done it before. And let's say I'll evaluate, before I do that, I want to make B equal to I, and I'll make G, just so that people get a rough guess as to what I might be doing with these numbers, and that can be the opposite. And then in here, I can't just type in B, R, and G. I need to evaluate. Now, I could grab all the commands out of the calculator, but if I'm thinking about this, and this will make it more obvious to participants what's happening, and the eval is just short for evaluate. So RG, I'm trying really hard not to say these words, just in case people haven't figured it out yet. And of course I'll need to end 4. Save it. Let's see if my coding worked. So, we'll run light.
Cool. I like that.
So it's blue. Well, it was blue. It's changing a little bit. So essentially what we're doing is saying let's set the color to red, green, and blue. And at the start, blue is equal to 0, and then green is equal to 255. Oh, here we go. No, I tell a lie. Let's put a, go back. Let's put a weight in here. Maybe that's what it was. It was too fast, but people might not have seen it. Let's try it again. There we go. That's a bit better. So we saw it start off green and then went through to blue, and it's done. And all it's doing is changing from red to green, from blue into green or green into blue, depending on what sort of value you set the green and the blue. And of course we could put some red in there. So it's 256 different scale colors for red, green or blue. It's a special diode called an RGB diode. So it has 4 pins. This particular one has a common earth, and then you can send the different voltages into the 3 pins, depending on how much red, green and blue you want. Now, we also have a light sensor, which I don't have time to show here, but there's a light sensor as well that picks up the amount of light hitting the actual sensor itself. Now, if we think about that, if you put, say, a red filter in front of that light sensor and you're shining, say, a blue light, you won't get much light through. If you put a green sensor in front of it, depending on what light, you may or may not get light on the sensor. So by putting 3 different filters, keep the light color the same. If you put 3 different filters and measured the 3 light intensities that were reaching that light meter, students could start to figure out, with a bit of thought and science, physics if you like, maybe or approximately what color the light was. And now we're starting to get a sense of how a scanner works, or a color scanner might work, is using different receptors that are sensitive to red, green or blue light, and therefore working backwards to figure out what color that it's actually viewing. So I see that we're out of time. Hopefully people have some idea on what the Innovator does from our little video display there. I'll switch him off. And that's pretty much it from me, and hopefully people have also seen that it's fairly easy to program. There's not a lot in that program, but you can make it a lot more sophisticated if you want.
Yeah,
Back to
and
you, Ron.
some great starting points there. So back to me. I've again endeavoured to share my screen, and this time it is working. So you get to see a photo of me. Thanks, Peter. I reckon it's fantastic, and the bravery of using a camera during a webinar. Participants.
I was pretty scared it was going to show me. More scared for the participants.
We tend not to use cameras, and there's a very good reason for that. In the calculations there, I got some messaging from Chris Orison, who said that he's actually weighed the Inspire, and he said that it has a mass of 240 grams, and hence his calculation, following the same lines that Jim and I did, to get our value of 5, Chris came up with 12, and those being the arguments, I guess he's got the best answer.
Oh,
he wants to know what his prize is, Peter.
Tell him that I'll shout him a drink at the MAV conference, in the happy hour at the MAV conference at the end of the year.
Yeah. That sounds fair enough. Okay, participants.
Or maybe a pale ale from our good friend Brian.
From the Akindander Brewing Company. Yes, we can see if we can get that arranged as well. And yeah, just a quick word thank you to our sponsors. So, and of course, thank you to our presenters this evening, Peter Fox, who you've just been listening to, and Tim Grabovszky, who started us off with the coding. I think the activities presented are absolutely brilliant, and a particularly good illustration of the, well, we talk about STEM, but what I'm particularly impressed to see is the science and the mathematics combined with the technology to really show the engineering. When you get through to talking about colour scanners and so forth, it's the engineering, and it's what makes this work. That's what we hope to direct our students towards, as they will be the engineers of the future. I'm about to close the webinar. When I do, you will be given a feedback page. If you're as impressed with the presentations as I have been, then please give us that feedback. And some people have been asking for the TNS files. Within 2 days, we give you your PD certificate, and also accompanying that, the link to the web page where you can download the TNS files associated with this evening's webinar. This webinar itself will be edited and maybe chopped up into little pieces and available for viewing on our YouTube channel. And if you're like me, I like actually using some of this as part of the classroom instruction, because so much of it I think is useful for students. For those of you who didn't have operating system 4.4, this is where you can download it. If you go to, if you just type into Google Texas Instruments Australia, this is the page you will get. You've possibly already done that. You know how to find your way to the 10 minutes of codes. If you've never done coding before, and a few people said they hadn't, then that's a great starting point, especially also for students. And this one here to upgrade to the latest operating system, that very conveniently adds that program editor as a new page. I hope you've enjoyed this evening's webinar. On Thursday evening this week, if you'd like to see pretty much the same sort of thing, but adapted for the TI-84 system, if you're looking at different systems, then that will be happening on Thursday evening, and with a couple of other different presenters, one from one from Queensland and one from Northern Territory. So thank you once again to our presenters this evening, and thank you to participants, and thank you for your feedback during the chat and the chat and the live polling. And I wish you all good evening.